Hello everyone. I am Ndumiso Buthelezi. I'm sure y'all can hear me, right? I don't want to start talking then.
Yes, sir. We can hear you.
Okay, that's nice. Let me see. I'm gonna try to share my screen. Okay, where is this? Yeah, there it is. All right, then. So this is gonna be my presentation for today. I'm gonna be talking about MediaPipe, hand tracking, and gesture recognition. So MediaPipe is this Google product. Not many people actually know it's from Google, but I recently found out myself it was from Google when I wanted to do some hand tracking and gesture recognition. So what exactly is Google AI Edge, the MediaPipe hand tracking thing? So it's machine learning powered, meaning that it utilizes advanced machine learning models for real-time hand tracking. Also, it is very diverse in its application as it's ideal for things like augmented reality, gaming, which is the niche I chose, and then also sign language along with human computer interaction. So we actually use a lot of media pipe things or a lot of gesture controls in the technologies we use today, as I'm going to be making such examples in my speech. So we have landmarkers and what it actually does. So usually it detects 21 key points on each hand, providing a detailed hand area. Its output usually has hand landmarks, an image or world coordinates, and its handedness. So meaning it usually can detect whether the hand is left or the hand is right, in a sense. So it is usually great for drawing skeleton overlays, motion tracking, and building custom hand interactions. And that can be very beneficial if you want to build your own game where you don't actually have to touch the button for the car to go sideways or for the car to go forward. All right, then. So we're gonna move on to the next slide where it's more about the gesture recognizer and what that does. So the gesture recognizer classifies gestures using landmarks again, recognizing common actions. So the common gestures you usually have is your thumbs up, your thumbs down, your fist closed, and your palm open, one hand index pointing to the sky, the peace sign, and some people call it the devil sign, but I just call it the rock sign. Then it also has gesture-based controls, so which also is an intuitive controls for AR and VR and other interactions you might have, along with sign language basics. So MediaPipe gesture recognizer supports prototyping for sign language recognition, which is can be very useful in now making sure that the disabled can be understood by people who don't really understand sign language or were never interested in it. So the key differences between the two. So the output you usually get from a hand end marker is raw 21 key points, whereas from a gesture recognizer, you get a predefined gesture. And in customization, with hand land markers, it's very high. You can pretty much define how you wanna customize your thing, and you can define what each key point actually means in your code. And then in gesture recognizer, it's built in plus custom gestures. So with gesture recognition, you're usually going to be using the built-in features, which we already showed you above, how they usually are, the index, the peace sign, and all the other hand gestures. And you can also add your own custom gestures on top of the built-in one. So this is usually good for developers like me who don't like to spend a lot of time building stuff from scratch. I usually like plugging in things together and writing a little bit of code here and there just to make things work. I don't want to go ahead now and be making new things just because I have to make this one use case work. So in terms of the use cases it has, the hand land marker is good for tracking movement, whereas the gesture recognizer is good for controlling features. So I'm going to be focusing mostly on the gesture recognizer because that's where my project is geared towards. So in performance benchmarks, so I took these performance stats off the internet. Usually it's the Pixel 6 device from Android Studio that you usually they be making these test landmarks on. So it goes 17 milliframes per second for landmarker on a CPU. But now if you switch to a GPU, it's gonna massively decrease the amount of time it takes by almost like 4 to 5 milliseconds to 12 milliseconds now, meaning that on a GPU you get a faster performance as GPU is way better at processing speed than CPU. Along with the recognizer, though, it's a bit different now. As the recognition, the CPU often performs better than your GPU. So it's pick and choose. Depending on your use case, you can pick which one works for you in terms of if you want to get that extra boost of speed or that extra boost in performance. And they both run in real time. So another thing is the implementation options. So the implementation options you can say are almost endless because it's available for Android, it's available for Python, and it's also available for web, which is JavaScript. So it's cross-platform in a sense. And also the AR flexible mode. They supports image. It also supports video decoded frames and live stream, which is the camera inputs. All right, let's go to the applications. So as I said, we have AR augmented filters. Snapchat was a very big user of this type of use case, and Instagram style iterative experiences. And the second application would be gesture gaming, controls games with natural hand movements. And the third one would be touchless UI, navigate interfaces without physically touching the UI. And another one is sign language. We can develop recognition prototypes. And the fifth one is robotics and IoT. So you can control devices with hand gestures. So there's a lot of applications you can do with MediaPipe, and there's a lot of things it actually applies to. So I wasn't able to get the code running because I'm on a Google call, and the code actually uses OpenCV to actually show you guys how the camera works. So I'm just gonna first show you the sneak peek of the code in terms of the things, the different packages we were importing from PyGame to computer vision to MediaPipe and to the math and the random all the time. So since I cannot show you guys exactly how the code runs, I'm going to show you a video of me playing the game I was going to present right now. Okay, so on your screen right now, okay, let me just first switch the screen I'm sharing at so you guys can actually see. All right, I think this the one. Okay, I'm sure you guys can see the video now.
Not yet, sir.
It's not yet being seen. Huh. Shit. Is it visible now?
Yes, now we can
Yes.
see.
Oh, nice. So I was at the lab here when I was actually doing this. I was testing the app out. These were actually the early stages of building it. So I had someone record me as I was testing it out. So here you can see me forming a full fist. And now I'm doing a palm up so the car can actually deaccelerate a little bit from the red blocks. So I made a whole game basically where you can control your car without even touching a single button on your computer, where you just move around with your hand and goes left, goes right. There's coins, there's bonuses, there's an edit those, there's a few feature, but the major component was focusing on mostly was the media pipe and gesture recognition part of it. So this game kind of iterates that whole process of using media pipe. And the language I was using, the route I chose was I made a Python game as you saw from the Python imports I just showed you earlier. So this concludes my presentation. I think it should be good enough for the time. Thank you very much for the opportunity for me to showcase my products here with you guys.